In this video, we are going to understand Huygens principle of secondary wavelengths, and also I'll be showing you a simulation to demonstrate this principle. Alright. First of all, remember one thing that Huygens principle is the basis of wave theory of light. Okay. It actually tells us that how a wavefront propagates through a medium. Like we have understood that how a wavefront is formed. Okay, we have seen different types of wavefront or different sources of light. Okay, we have seen spherical wavefront, we have seen cylindrical wavefront, we have seen plane wavefront. Okay. But this Huygens principle is actually going to make us understand how this wavefront propagates through any medium. Right. So first of all, I'm going to be writing down the principle, and then I'll be showing you the simulation. Right. Now, according to Huygens, each point on a wavefront, is a new source of secondary waves. That means they will be behaving as a new point source, right? Which adds up to give a new wavefront at later instance. So that means whenever whatever wavefront we consider, whether it is a spherical wavefront or the cylindrical wavefront or plane wavefront. Okay. So if I consider number of points over that wavefront, so those points will behave as a new source of disturbance. Okay, we will call them secondary waves, and this new disturbances will actually going to give us a new wavefront. Okay, certain instant. Okay, a certain later instant. Now, to understand this principle more clearly, let us just see this simulation. Now, this point which you see here, this is a point source from which light is going to emit in all directions uniformly, in all three-dimensional direction. Okay, and since this is point light source, so the shape of the wavefront formed by this point source will be spherical. Okay, we have studied about this. So let's say that. So now this point source is emitting light in all directions uniformly, and because of which this is my first spherical wavefront. Alright. Now if you've observed this wavefront, I have taken few points over there. Okay, I've taken like around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I've taken around 14 points over this wavefront. Okay, so this points which you see, they will now behave as a new source of secondary waves. That means they will be behaving like a new light source. Okay, and light is going to come out from this new point over this wavefront. Okay, so since they are point source, so the shape of the wavefront for each one of them will be again spherical, because they will be emitting light in all directions uniformly from each individual points. Okay, let's say that after certain instant they have started to emit light in all directions uniformly, and because of which you can see here they are now having their own wavefronts. Okay, so each point is emitting light in all directions, and because of which they are having their own wavefronts, spherical wavefronts. We call them wavelets. Okay, these are your secondary waves, or sometimes we call it wavelets. Now, if you have observed this diagram, what I have done, I have taken a tangential surface in forward direction. Right, this black circle which you see, solid black circle which you see, this is a tangential surface which is connecting all these secondary waves or wavelets. Right, so this is my new wavefront at certain later instant. Okay, so light has moved from this position to this position. Initially, let's say that at certain instant, the wavefront was somewhere here. You can see this is my gray shade. This was the original wavefront. Now light has moved from this original wavefront to another wavefront. Okay, so light has propagated from this point to this point. Again, we are going to use this Huygens principle. Again, we have considered few points over this new wavefront, and again, this wavefront, this points will be behaving as a point source, and they will be emitting light, in all directions uniformly. As a result, these points will be having their own wavefronts, okay? Because they will also be emitting light in all directions, right? So let's say that yes. So we can see here, these points, uh, the second wavefront, they are emitting light in all directions, because of which these points are having their own wavefront. Okay. Again, what I have done, I have again drawn a tangential surface connecting all the wavefront from the second wavelets from the second wavefront. Okay, these are the wavelets produced by the second wavefront. Right, and when I have drawn a tangential surface in the forward direction, this is again my new wavefront. This pink shade, pink circle which you see, this is my new wavefront. Right. So originally, your first wavefront was this sphere, which is in gray shade, and each point is emitting light over this wavefront. Whenever I consider certain points over this wavefront, they will be emitting light in all directions. Because of which we are having our second wavefront. Okay, this solid circle which you see, this is my second wavefront. So that means light has moved from this point to this point. Okay, and this pink circle which you see, this is telling us that light has moved from this dark black circle to this pink circle. That means this is our first wavefront, this is our second wavefront, and this is our third wavefront. So in this way, light propagates, yeah, with the help of wave theory and with the help of this Huygens principle. We are able to understand that how light propagates in any medium. Alright. So if I play this simulation, you will see that how light propagates probability. Alright. Now we are going to write down certain assumptions. Certain assumptions required to explain this Huygens principle. So first of all, our first point is, each point on the wavefront, any wavefront, the wavefront behaves behaves as a new source of disturbance, new source of disturbance called secondary waves or wavelets. Secondly, all this, all the disturbances propagate, or you can say spread out in all directions, in all directions with the speed of light of the medium. So from each point over this wavefront, when light wave is going to emit out, they will be moving out with the speed of light of that medium. Right? And third point, the new wavefront at any later instant is given by the forward envelope, or you can say a tangential surface in the forward direction of the secondary wavelengths. Okay, so these are the 3 points which explains Huygens principle more clearly. Alright. So the second point, we have already understood that this propagation of wavefront will be with the speed of light, okay, in whatever medium you consider. And this new wavefront, as you can see, this gray shade, this was the original wavefront, and they were having secondary wavelets. The blue circles which you see, these are your secondary wavelets related to this first wavefront. And when you draw a tangential surface in forward direction, this black circle which you see, this black circle is my new wavefront. Right. Again, if you consider a few points over this black circle, okay. So again, they will be behaving as a point source, and they will be emitting light in all directions. Again, if you see, you will be having certain circles in the third layer, and when you form a tangential surface in the forward direction, corresponding to this secondary wavelets in third layer, this pink circle is going to be your new wavefront. Okay, a third version of new wave. So in this way, and it continues, you will be having, again, these points will be behaving as a new source of light, and they will be emitting light in all directions. Alright. Again, from each source, okay, from each point source, you will be having circular wavefront. Okay, you will be having circular wavefront. And if you draw a tangential surface in forward direction, okay, something like this, if you draw, so that will tell you, or that will give you your new wavefront, a fourth version of the wavefront. Okay, so this circle which I am drawing now, which is tangential to all these circles. So this will be my fourth version of GeoGEBRA. Okay. So in this way, light propagates. Okay. Thank you.